So here we are doing another one of these videos. This one is going to be about balancing redox equations in a basic solution. I'm doing question 40 on page 185 in the textbook. So 40, and this is going to be question A. So we have a chromate ion and a S2O4 ion. So CrO4 -2 plus S2O4 -2. And that turns into CrOH3 and a sulfite ion. So Cr chromium 3 hydroxide, which is solid, and a sulfite ion. So I just put the sulfite ion first because I wrote that first, plus chromium 3 hydroxide. All right, so looking at this equation, if we do the two half reactions, we know the chromiums are going to turn into some other form of chromium. So we're going to put the chromiums in the same equation. And then the S2O4 does that. We can see that the sulfur, let's see, what is the charge going to be on a sulfur here? This would be sulfur 3, I believe. So you got -2 times 4 is -8. So this has to be +6. There's two of them, so it's 3. This is going to be 4 because -6 plus 4 is -2. So this is going to go from +3 to +4. You can see electrons are going to be lost. This will be your oxidation half reaction, and this will be the reduction half reaction. But again, to do these problems, you don't really have to identify them right up front. So if we look at this equation, we can see here that we have 3 oxygens. So on this side, I'm going to have to add no oxygens because that's a little boo-boo. Because if you got 3 oxygens here, there are 4 oxygens over here already. So it turns out that the oxygen has to be added over here. So that would be 1 water molecule would make 3 plus 1 is 4, so that would match our 4. Then we have to consider our hydrogens. We've got 3 hydrogens here plus 2 hydrogens there, and 3 and 2 is 5, so I'd have 5 H pluses I have to add on this side. I want to talk briefly right now about acids and bases. So in a basic environment, you don't really have these hydrogens, but we're pretending we have them, and then we will adjust the final answer at the end. So I'll remind you how to do that. So right now you do it just like we did the previous equations. We're just going to add one step at the end. All right, down here we can see immediately that we got 2 sulfurs here. So you need to deal with that before you deal with anything else. So you have to put a 2 there. That makes us have 6 oxygens. On this side, I have 4 oxygens. So how many waters will I need? 2 of them. So now, I think I'm ready to balance charges. Oh, H's. I got to balance H's down here. Forgot about that. So this is 4 H's. I don't have any H's on this side, so I'm going to have to add 4 H pluses. Now we've got to balance charge. So our charge on this side is -2 and -4 because there's 2 of these. So -4 and +4. The charge is 0. On this side, the charge is -2, so I'm going to have to add 2 electrons. Once again, 2 times -2 is -4, and this is +4, so it's 0. Got to make the charges equal, so I add 2 electrons over here. Remember me saying it was going to be oxidation. This equation is going to be an oxidation reaction because the charge is going to go up and electrons are going to be lost. Up here, our charge on the left side is +5 and -2, so it's +3. On this side, there is no charge. This is +3, this is no charge. So I'm going to have to add how many electrons over here? So that means then we're going to have to get the electrons equal. We're going to have to multiply the top equation and the bottom equation both through by something. And this something is going to be a 2 up here and a 3 down here, because 2 times 3 is 6 and 3 times 2 is 6. So that would make us have 6 electrons here, 10 hydrogens, 2 of these, 2 of these, and 2 of those. On the bottom, we had to multiply by 3, so that makes us have 6 waters, 3 of these, 6 of those, 12 of these, and 6 electrons. So now we're ready to cancel things out. First of all, we know the electrons cancel. Oops. So the electrons are gone here and here. We've got 10 hydrogens here and 12 hydrogens here, so I'm going to scratch out all 10 of these. And that's going to leave me a net of 2 on this side. So I'm just going to go ahead and write those down. So that's going to become 2. All right. The waters, we've got 2 waters on this side. We've got 6 over here. So both these are going to get canceled. I'm going to have a net of 4 on this side. So I'll put those down here, 4 H2Os. Nothing else cancels. So then I have 2 CrO4 negative 2s plus 3 S2O4 negative 2 yields 2 CrOH 3 plus our 2 H pluses.
Excuse the interruption. Alexander Hughes Troop. Alexander Hughes Troop. If you're in the
I have a little
building,
trouble with my digital
come
pen
down.
here.
Your ride is waiting.
That's supposed to be a plus sign. Then the other thing that's left over here is 6 SO3 negative 2s. All right, so that's our balanced equation, but that is assuming an acidic environment, and we know that it is not really an acidic environment. So here's how you handle that. You look for the H pluses, and everywhere you see an H plus, you add an equivalent number of hydroxides. I'm going to erase this and start again on that. I don't know why this is my little marker board. It's not living up to its full potential. All right, here we go. So now I'm going to add 2 OHs over here. 2 OH minuses. On the other side, there should be a charge up here of -1. On the other side, we also have to add the 2 OH minuses. Okay, these 2 on this side turn into water. See that 2 H pluses and the 2 OHs right there? They turn into water. So we're going to turn that into, we're going to turn that into 2 water molecules. So 2 H2Os. All right, there we go, finally. On this side, since I added the 2 OHs over here, I had to add them over here. So on this side, I've still got the 2 OHs, but now I've got redundant waters. So I've got 4 waters, and I've got 2 waters on this side. See the 2 right here? Over here, I've got 4. So I'm going to scratch both of these out. And I'm going to change this into a 2. Make that a 2. Okay, so now I have the final answer of 2 waters plus 2 hydroxide, that's OH minuses, plus 2 CrO4 plus 3 S2O4 yields 2.
Mr. Riley, if you're in the building, please call the main office. Mr. Riley, if you're in the building, please call the main office.
OH3 plus Oh, remember I scratched these waters. I'm having a little technical difficulty here, but those two waters were scratched out. Plus 6 SO3 negative 2. So, all right, now let's just double check and make sure we got everything balanced. There's supposed to be a 3 right here. I'm noticing I forgot to put it right here too, but that 3 right here should be right here and right here. Okay, let's double check, make sure everything's balanced. So on the left side, we have 2 times 2 is 4, plus 2 is 6 H's. On the right side, I have 3 times 2 is 6 H's. On the left side, I have 2 chromiums. On the right side, I have 2 chromiums. On the left side, I have 6 sulfurs. On the right side, I have 6 sulfurs. Now the oxygens, there's a lot of them, so I've got 3 times 2 is 6, plus 18. There's 24 oxygens on that side. Here, 3 times 4 is 12. 2 times 8 is 20. 22, 24. So everything is balanced, and that's our final answer. So again, when you have a basic environment, you do it just as if it was an acidic environment, and then add the same number of OHs as you have H's. Now turn those into water. You have to add the OHs to both sides. That's why I put it over here. Now once you have these waters created, then you'll cancel out some of the waters that were on the other side. So there were 4 over here originally, but when I added the 2 OHs, that created 2 waters. So it cancels out 2 of the 4 waters, and that's what shows up in our final net equation. All right, there you go, basic environment. You'll need to know how to do those to do a couple of the homework problems that are on the web page.